Okay, here we go. Perfect. Two factoring tricks. So we're going to do the same type of factoring that we've been doing, where A is 1. But as you guys just saw, we're going to do it where there's some slight differences. So the first thing that we just did is called a difference of squares. A difference of squares is something like this. X squared minus a perfect square. And as you guys noticed, what happens here is that the x term has a coefficient of 0. So we're trying to find two factors of negative 49 that add up to 0. And that just happens to be 7 and negative 7. Why do we call this a difference of squares? Well, we have a difference, and this is a perfect square, and this is a perfect square. So it's a difference of squares. Right? Now, the first term in this actually could be something other than just x squared. Because the way that this trick works is that we're just taking the square root of this here and the square root of this here, plus, and then the same thing with a minus. So I could have like 4x squared, and you guys would actually be able to factor this as well. 4x squared minus 100. What do you think our factors would be?
10 and negative 10.
So 10 and negative 10 are the factors of 100, but what about this 2x squared? What am I going to do there?
4.
I mean, yeah, the 4x squared. So instead of just having x plus 10 and x minus 10, I need something that multiplies times itself to give me 4x squared, which is 2 what?
X squared.
2. Now, do I need a squared here?
No.
Why not? What is 2x times 2x is
4x squared.
Is 4x squared.
So it works.
What would 2x squared times 2x squared be?
Be 4x to the fourth.
4x to the fourth, yeah. Right? So I'm just taking like the square root of this, which is 2x, and the square root of this, which is 10. Let's do a couple more examples like that. So what if I had 16x squared minus 4? What would I have next? How would I factor that?
2 and negative 10.
Okay, 4x.
Minus 2 and 4x plus 2.
Nice. 4x minus 2 and 4x plus 2. I love how you said the minus first and then the plus. I've been writing the plus first and then the minus, but it doesn't matter, right? It's whatever way you remember best. So it's just a pattern, right? The difference of squares pattern. Okay. The other thing that we just looked at, this is called factoring out a GCF. So this is kind of our second trick. Factoring out a GCF. Do you guys remember what GCF stands for? A greatest common factor. Right? So if I have something like, I'm actually going to do it this way. So if I had something like x squared plus 3x plus 2, I know how to factor that, but I only know how to factor it because there's a 1 here. So if I then multiplied everything times 2, 2x squared times 6x, or sorry, plus 6x plus 4, technically you guys can't factor this because it doesn't have a 1 in front of the x squared. But if we reverse the distributive property, if we pull that 2 back out then you can. So what factoring out the GCF means is looking to see if every term has something in common. And then you write that out front. So every term has a 2 in it. And then you just kind of think about the distributive property. 2 times what would give me 2x squared? Well, how about x squared? Because 2 times x squared is 2x squared. 2 times what is going to give me 6x?
3x.
3x. And 2 times what is going to give me 4?
2.
And now I can factor this. So I just only factor this. I leave the 2 out front. And I factor this. And I see that my factors would be x plus 2 and x plus 1. And this is actually the best way to do this. This is a fully factored form. One of my factors is 2. So instead of actually having 2 factors, I now technically have 3 factors. 2, x plus 2, and x plus 1. Okay? So let's do another one like that. What if I had something like this? 10x squared plus 50x. 60. Can I factor that in that form?
Yeah.
No, I can, but you guys can't. Why? This right here. Right now, you guys have to say to yourselves, hey, there's something in front of x squared, so we don't know how to factor it. Right? But how is there a way with this one to make it so there's nothing in front of x squared anymore? Yeah, how do I do that?
That thing.
Yeah, what would it look like?
The 10.
So I can pull out a 10, and what's left behind? 10 times what gives me 10x squared?
X squared.
X squared. 10 times what gives me the 50x? 5x. 10 times what gives me 60?
6.
6. Okay, I'm going to leave the 10 out front, and I'm going to factor this thing in parentheses. What do I get? Factors of 6 that add up to 5.
2 and 3.
2 and 3. Right, and this should be kind of, that's already what we knew how to do before. Okay, so pull out your greatest common factor, and then just factor what's left. Does that make sense?
Yeah.
Good.